All right, well, welcome back to another exciting episode of this Introduction to Algebra, this Algebra 101 that is Coach Maxwell's class. So we've been talking about solving systems. We've kind of introduced this, and we said that a system of equations, it's simply two or more equations which may or may not exist. So make sure we know that when we're talking about a system here, this system, that's simply two or more equations that may or may not intersect. Make sure you know that. I'm going to say it one more time so you make sure you write it down. A system is simply two or more equations, two or more lines which may or may not intersect. So we look at them. Well, they can either intersect, they can be lines that cross, or they could be parallel lines. So we look at lines that don't intersect, and that's what we're talking about. So as we go here, now before we start solving some of these by graphing, which is what we're going to do tonight, we need to look at kind of classifying these systems. So there are two ways we can classify them. We can classify systems as being consistent systems, and these are consistent. They have a solution, okay? These are lines which intersect. They have a solution. In other words, they intersect, okay? So these are going to be most intersect. Sorry, I can't talk and write tonight. So these are most of our lines. Most of our lines have a solution. They intersect. But we do have some that are called inconsistent. Okay? Inconsistent. So these are lines which don't intersect. They have no solution. Okay? They have no solution. These are lines which they don't intersect. They don't intersect. Now, ones that don't intersect, when you look at those could be lines which are parallel, okay? Those could be lines which are parallel. Or we're going to also talk about in class, and you'll look at them next year, those could be lines that are skew. So those are lines that anyway, they don't intersect. They have no place where they cross. They're lines that never cross. So they're called inconsistent. Now, when we look at consistent ones, there are two different ways that we can, two different possibilities with consistent systems. They can be independent, okay? They can be independent, and these are most of our lines. Most of our lines are consistent, independent. This means they have one solution, okay? Most lines, they intersect at one place. We look at them, they turn around and they cross right here. These two lines cross, they intersect. There's that one consistent. That's an independent, consistent system. But in addition to independent, we sometimes have ones that are called dependent. These are lines which have an infinite solutions. Infinite solutions. Now, I'm sure some of you are going, Coach Maxwell, how can they have infinite solutions? They're lines. They go straight. They either intersect or they don't. Well, this is kind of sneaky. This is what happens when we have two lines. So y equals x plus 2. And what about the line y equals x plus 2? Well, they're two different lines, but they're the same line. So they have infinite number of solutions. Why? Because they're the same line. They intersect everywhere. Because they intersect, they cross each other, they touch everywhere. So those are called dependent consistent systems. Ones where you have two or maybe of the same line, or maybe you've got three of the same line. Usually they're kind of written in different ways, with this second one down here, maybe it started off as saying, is looking like y minus 2 equals x, but then when we move the 2 over, it becomes the same thing. So usually they're not written exactly the same, but they're the same line regardless. All right, so let's look at some and let's solve them. Let's solve them graphically. So to solve the system graphically means we're going to find where do they intersect. So the first thing is look and make sure they've got a solution. So we've got two here. We're not really worried about we're going to look at them and see, okay, they've got different slopes. They have different y-intercepts. They're not the same line. So they've got different slopes, different y-intercepts. So they're not the same line. So we know from looking at this, because they're not the same line, they're not consistent dependent. Okay. So the question comes in, well, are they consistent or are they inconsistent? Remember, consistent intersects, inconsistent won't. Well, for us right now, the only way they're going to be inconsistent is if they're parallel. Well, parallel lines, make sure you write this down right now. Parallel lines have the same slope. Parallel lines have the same slope, which in our equations up here is our 4 and our 1 that's right in front of this x. Well, these two don't have the same slope, so that means that they do intersect. That means that they are consistent, and because we know that they're not the same line, they're going to be consistent and independent, so they're going to intersect one place. So let's graph the first one up here. This first one we're going to graph in blue. So we know we start at -2. It's got a slope of a 1. Okay, it's got a slope of a 1, so we go up 1 over 1, up 1 over 1, up 1 over 1, 1 over 1, 1, 1, 1. I could keep going as far as I wanted to, or I could go down 1, left 1, down and left, as long as I really wanted to. But the point here is that we've got this line that looks like this. So there's my line. There is y equals x minus 2. It's graphed. So let's graph the second one. Let's graph this one right here. Y equals 4x plus 1. Let's graph it in red. So y-intercept is 1, so we start at 1. And it's got a positive slope. That means I can go up 4, 1, 2, 3, 4, and to the right 1. Up 2, 3, 4, and to the right 1. Or I could go down 4, 1, 2, 4, and to the left 1. Down 2, 3, 4, and to the left 1. So we've already figured out, we've already seen, I guess, come on now, draw my line. We can already see that these two have a solution. We can see where that solution is. As a matter of fact, there is their solution to these. Oops, sorry, look at my line here. Here is my solution to those. It's right there. So what is the solution to it? Well, the solution is -1, -1, -2, -3. The solution is -1, -3. There is our solution to this system. We're always trying to solve it and find the solution. There's our solution at -1, -3. So you just solved your first system of equations by graphing. So let's try another one. So we've got this one here. Let's look at it first of all. Do they have the same slope? Don't have the same slope. The top one here has got a slope of -2. Bottom one has a slope of 1. So the slopes are different. So they're not going to be parallel. They also can't be the same line. So we know we're dealing with a consistent independent system. So let's go ahead and let's graph this first one. Y equals -2x plus 3. Start at the y-intercept. 3. 1, 2, 3. Now, because our slope is negative, we know that it's going to go down and to the right. So I need to go down 2, 1, 2, to the right 1, down 2, to the right 1, down 2, to the right 1, down 2, to the right 1, or I could go up 2, to the left 1, up 2. And I'm just doing this because for me, it makes it a whole lot easier for me to graph this if I have a bunch of points. Okay, so there's the first one. It's graphed in blue. Let's graph the second one here in red. So y-intercept is -5, -5, -1, -2, -3, -4, -5. And it's got a slope of 1, so up 1 over 1, up 1 over 1, up 1 over, oh, guess what? Found the solution already. Keep going here if I really wanted to. Give me enough points to turn around and graph this line, but we can see where they intersect. And the point of intersects, the solution is right here. There's my solution. It's at 1, 2, 3, at 3, -2. So my solution to this system is 3, -2. So found my second one. All right, so let's try this one. All right, so do me a favor. Go ahead and hit pause on here. Sketch the graph of these two. See if you can come up with a solution, and then hit play again, and let's see what you come up with. Okay, well, hopefully you've got yours. You found it, so let's go ahead. We look at these two. First of all, the top one, let's check our slopes. Make sure we're going to have a solution. Slope's -3 or -3 over 1. The second one, the slope is 1, or you could say it's 1 over 1. They're not the same line because they don't have the same slope, same y-intercept. They're not parallel because they don't have the same slope. So we know we're going to have a consistent independent system, meaning they intersect and they intersect in one place. So let's graph the top one. I'm going to graph it in blue. Start at 6. 1, 2, 3, 4, 5, 6. It has a slope of -3. So I go down 3, down 1, down 2, down 3, to the right 1, down 1, 2, 3, to the right 1, down 2, 3, to the right 1, down 2, 3, to the right 1. Sounds like some kind of funky, freaky dance. Or I'm going up 1, 2, 3 to the left 1. So So we turn around and we look at this. As I look at this line, and that's not too bad, fairly straight. All right, so there's the first one. Let's graph the second one. And it starts at y-intercept is -2. It's got a slope of 1, so it goes up 1 over 1, up 1 over 1. Oh, found my solution already. Turn around and draw my line just so we can show it. Now let's write what the solution is. The solution to this system, it's right here. There is my solution. It is at 1, 2, 0. So my solution here is 2, 0. So there you have it. That's how you're finding the solution to a system of equations by graphing. Hopefully this clears up. We're going to do lots of practice of this in class. But until then, I will see you tomorrow. Have a good evening.